Hello, ladies and gents. Welcome to Jason's classroom. Today I'm going to explain what is equilibrium to you. The word equilibrium totally has four meanings, actually more than that. The first meaning is related to physics balance. For example, if a person is walking and is down over a rock, but he finds his equilibrium and stands still. The second meaning is saying a person has a cleansed mind, like a monk. No matter how much voice is around him, he's still able to sit there. The third meaning is related to the economics. For example, a factory provides two Nike shirts, Nike shoes to the shoe stores, and the shoe store, at the same time, the shoe store need two Nike shoes. So we can say that the amount of demand of the shoes and the amount of supply of the shoes are matches. We're saying the shoe store is in equilibrium. Right now, we finally get to the really main topics, the big topics, dynamic equilibrium. Have you ever asked yourself, what is dynamic equilibrium? I know it's obvious. I know it somehow confuse you. And I'm here to help you to get a better understanding about dynamic equilibrium. Dynamic equilibrium totally has three types. I'm going to explain the three types, and then I will tell you what is dynamic equilibrium. So one of the type of dynamic equilibrium is phase equilibrium. Phase equilibrium involves a change in state for a substance. You all know that, right? And in a container filled with half the water is in a closed system. The liquid water undergoes, this is liquid water, and then it undergoes a chemical reaction to become a water vapor. Like you will see somehow it's like this. These are some of the bubble around the container if you put the container there for a while. And at the same time, the water vapor undergoes a chemical reaction to become water liquid. So the chemical equations I can write is water liquid become water vapor, and at the same time water vapor become water liquid. Because where's this bubble come from? No, it's not bubble actually, it's come from liquid around the container. It comes from the liquid become gas, and gases become this liquid, and then going back to the liquid again. So this equation explains what happened in that container. And then the second type, another type of dynamic equilibrium is solubility equilibrium. Solubility equilibrium involves dissolving a saturated solution. Here's an example. Also in a container filled with half the water, it's a closed system, definitely. We all know if you put a sodium chloride into the water, it will completely dissolve into a sodium ion and chloride ions. Because sodium chloride has a really high solubility constant. However, not like sodium chloride, calcium fluoride has a small solubility constant, which means it won't completely dissolve in water. So what happens if you put calcium fluoride into the water? It will one calcium fluoride will dissolve, it becomes the calcium ion fluoride. At the same time, calcium ion and fluoride becomes calcium fluoride. So the equation, if you have to write the equation, it will be like this. So I mean, water here this is water. Calcium fluoride put in the water. So the equation I can write is that calcium fluoride become calcium ion and fluoride ion. The center calcium ion and fluoride ion become the calcium fluoride compounds. So the last example is chemical equilibrium. Chemical equilibrium involve chemical reaction within this container is a closed system. One nitrogen gas react with one hydrogen gas to become one ammonia molecule. At the same time, one ammonia molecule break out to become one nitrogen gas and one hydrogen gas. You can see the forward reaction and reverse reactions. Forward reaction and reverse reaction are occurring at an equal rate. So no overall change is taking place. Finally, one ammonia gas here, and then one nitrogen gas and one hydrogen gas in this container. So no overall is taking place. In other words, the concentration of all reactant and product are relatively constant. So this is really important, relatively constant, because in all three type of dynamic equilibrium, is the reactant and product are all relatively constant, because the forward reaction and reverse reaction occur at an equal rate, so no overall change is taking place. And also, if you look hard into the reaction, you can see they have a comment actually here. What does that mean? The forward arrow and backward arrow is mean the reaction is reversible. So this is a rule of the equilibrium, I can say that. And also you can see, in order for the equilibrium to take place, it has to be in a closed system. Like this is a sealed container, I can say that. And next, I'm going to tell you how to write the equilibrium law equation. This is the basic equilibrium reversible reactions. And in order to write that, is equal to equilibrium constant equal to the product over reactants. And you write the molecule. You write the molecule in the concentrations. The unit is for mole per liter inside the D, and then C, and then B, and then A. And C, the small capital of A, B, C, D is actually the coefficient of in the equation. So what should we notice when we write this equilibrium equation? Actually, constant equilibrium equation. Actually, we should notice is we don't need to write the solid state and the liquid state in this, because the solid and liquid, they can change the concentration. However, the gas and aqueous state can change, because how to change the gas is that you change the size of the volume. You change your volume, you can change the concentration of the gas. And aqueous, you can add more water, it will dissolve more. So if you see anything, any solid state or liquid state in the equation, you don't need to conclude you don't need to write it in the equation here, but you have to write it in here. Yeah, so finally I say that this equilibrium is kind of like really surprised me because equilibrium is hard to learn, but it's fun actually. So thank you so much for hearing the Jason's classroom, and I'm so happy to teaching you guys. And good luck for your exam. Good luck for your exam, guys. Have a good day.